Hey Wendy, this is Mike Fortner. I'm just going over your lab here. I have some issues, but I want to make sure you're clear on. The first activity you were asked to graph this data, which you did do successfully. There are a couple of exceptions here. There's no label on this really about what this is. I guess that really would count, but I don't, formally speaking, I can't tell exactly what that is, and I don't know what units. Wait. Okay, I do have some, I don't have units here, but I do have some numeric values here. So I'm not going to worry about that too much. But this graph is in general the correct shape. Now what you went wrong on here, I don't know quite what was going on here because the average speed between 0 to 10 seconds, that's up here on the graph that you do. 0 to 10 seconds. 0 to 10 seconds is basically from here to here, which is just here to here. So that's 40 minus 0 over 10 seconds, so that's just 4. I'm not quite sure where that came from, but it looks like you had a bad understanding of that, and I'm sorry about that. All right, so with this right here, you improved on this quite a lot. You did this one reasonably well. Second question. The third question, and anything about slope, you evidently don't have a good understanding of that, and that's something we should try and work on since this is in mechanics. It does not represent, slope does not represent in this graph acceleration or deceleration. It represents positive or negative velocity. In this one, when the slope is 0, that simply means it's not moving. It's not a change in acceleration, that's just not moving. Now, question 5 here was about the interval of time or interval of distance between 70 and 55 millimeters. 55 meters. That means it starts off at 70, goes to 15. The time period for that, I'll go back up here and look at it, was going from here to here, here to there. Sorry, gotta move this up and down. Doesn't work that well for me. So the displacement went from 0 to time equals 0 to time equals 50. That was just 55 meters because that's as far as it went. That was 55 meters on your graph. Again, this is out here. The correct number for this, which is you just add up what you had in the graph, was 85 meters. This number here, again, represented the change in velocity. Nothing to do with acceleration. Now, you did have a correct value of 3 here. I'm not quite sure where you got that was going to be acceleration. It was not slowing down here. It was not deaccelerating. It was going in the opposite direction. This, you just take the overall value that it went divided by the time. So it was 50 seconds, and your total distance was 55 meters. So it's 1.1 meters per second was the average velocity. It has nothing to do with all that. I'm not really sure where that came from. And your question here was technically right, but I'm not quite sure what you meant by this. This is kind of the accepted answer that my reference gives. And that's what I score students against. Okay, I'm going to stop this for a second. Okay, so here was your activity 2 table. Those are your numbers there, I think. This was the graph that looks more or less correct. I'm not going to give you a hard time over that one. And this was the constant velocity that you were going each one of those times. That does not go to that one. That would go for another one that was supposed to be down here. Now, I don't really know what this means. I couldn't determine that. I didn't see those numbers. And this region here, basically 1 to 2 seconds, doesn't correspond to anything that I was familiar with. And I don't know what you mean by that phrase. Now these findings here and that, okay, I want to show you something here. This was time and distance. And this was time squared in vertical axis, I'm assuming to be the difference. Your values you have there, I'm not sure I know where those came from either. This, what you see here, is the key that I was given to use for this. So this is displacement versus time for these numbers here, which should correspond with yours. These are examples of it, but this is for any kind of an object going down that path at a constant acceleration. If you go down a constant acceleration, then these distances here over time will expand like this, and that would end up being a parabola. When it's time squared, if you do a best fit line through this, this should be a line, and that's time squared. Neither one of those look much like this, and there's no real scale here, and there's no real explanation of what this is. You do say it's a parabola, but I think maybe you looked that up somewhere to see what the answer was. I don't really believe you, I mean, I don't see how you would get from that information, I apologize, but I don't see how you'd get from this information up here that that's a parabola. I don't see a scale or units or anything like that. So this one right here, this indicated that it might be a line or it could be a parabola. Not quite sure what you mean there. This is what shapes do these, what do these shapes mean? Well, this is what they really indicate. That the graphs mean the displacement is directly proportional to time squared. That's all it means. And I don't really understand what you're attempting to say here, so that's perhaps on me. These other expressions down here at the bottom, I've got no issues with, so I'm not going to waste your time with that. There's nothing else further I need to worry about there. Okay, I'm back now. Now this is the actual where I determine your grade, and so I want to go over that with you and tell you why I did what I did here. It looked to me like you did a yeoman's job here of collecting the data. There's some data collected properly. That's good. Here I'm just asking you to read the feedback because your interpretation of the data here was not as good as it should have been. I mean, I don't think you really understood the problem, and that's something that we should work on. So here on this one, you showed in both these cases, you showed some progress at that, but I think you made it way too difficult, made the problem way too difficult. So here is both cases about this. And finally, pardon me, and finally on this one, when you did write a few things about it, but your writing was not indicating a good appreciation or interpretation of the information. And that's what you need to work on in the upcoming projects and labs. Don't overthink them. I'll put a comment here at the end. I may just put this link here. You may just see that. And so overall, your score on this lab was a 68, and I hope you can understand 68.5. And I hope you can understand what that is, well, that's there. You should be, when you get this link right here will be what I'm telling you right now. Anyway, if you've got questions about that, you're welcome to email me or text me, and we can talk about this. But I think you really have to work on your understanding over the current assignment and on the next project, the next assignment. If you need help, I'll be happy to help you as best I can.